within the Malta Chamber. We are, first of all, proud to be hosting this webinar today. Circular economy as a topic is a topic that we have been pushing on for the past months, the past year and a half, I would say. As a committee, we are made up of various members coming from different sectors who have the environment and circular economy at heart. So our work is involved with putting forward proposals, both to the authorities, to central government, in terms of achieving circularity. We are firm believers that those entrepreneurs, those companies that are today making hard decisions in terms of lessening their impact on the environment, in terms of achieving circularity, will be those leading tomorrow's economy. So with circular economy, we see a great opportunity in reality, a great opportunity to lead the markets of tomorrow, okay? A great opportunity towards what we believe could be the next revolution, the next industrial revolution. Today we have a number of interesting speakers who will be sharing their experiences and their knowledge with us. So without further ado, I would like to introduce the first speaker on the list, Engineer Anthony Rizzo, CEO from CE Malta. So Anthony, in your hands, please.
Thank you. So good afternoon to all. First of all, I would like to thank the Malta Chamber for the invitation and for the initiative they've taken to organize this webinar. But before proceeding any further, I would like to introduce the agency, Circular Economy Malta, an agency within the Ministry for the Environment, Climate Change and Planning. Originally, the agency was set up in 2018. Originally, the objective was to establish a beverage container deposit scheme within the context of a circular economy. It was originally called RRRA, Resource Recovery and Recycling Agency. However, in May of this year, the agency changed its name. During the initial startup and the months that followed of RRRA, it was clear that the agency needed to widen its vision, its responsibility to act as a facilitator, supporter, to assist in the transition from a linear, as we all know, take, make, dispose model to a model based on circular economy. However, what do we mean by circular economy? How do we define it? Currently, circular economy is a popular concept promoted by the EU, by several national governments, and by many businesses around the world. However, the CE seems to be a collection of vague and separate ideas from several fields and coming from semi-scientific concepts. However, in preparation for this webinar, I did a research and I found the definition of the World Economic Forum, which I believe is a bit scientific and it reflects the principles behind the circular economy. And I will share this with you. So a circular economy is an industrial system that is regenerative by intention and design. It replaces the end-of-life concept with restoration, shifts towards the use of renewable energy, eliminates the use of toxic chemicals, which impair reuse and return to the biosphere, and aims for the elimination of waste to the superior design of materials, product systems, and business models. Therefore, I believe that the circular economy contributes to all the three dimensions of sustainable development: the economy, the environment, and the social. Using the definition, I try to extract some principles from the definition of the World Forum. And I thought of the following. So one of the principles behind circular economy is regeneration. In other words, switching to renewable sources of energy and materials, sharing of assets, reuse of products, extending the product life cycle through maintenance, design for the purpose of durable use, optimization, obviously improving the efficiency and performance of a product and reducing waste, looping recovery of products and components for recycling of materials, exchange, the use of new technologies, selection of new products and services, and I think rather an innovative principle is the virtualization, direct and indirect, the materialization replacing actual media by intangible media. Normally this is carried out by the big, the Googles, the Amazons, the Facebooks, etc., where they create showrooms, they create an environment that is virtual and not reality. Having listed these principles, I now would like to establish where or how they support the 3 pillars of sustainability. So I will start with what's in it for business, with the economic contribution. Obviously, reduced raw material and energy costs, minimized use of costly and scarce resources, reduced waste management costs, and new markets for the resources that are recovered within the circular economy. From the environmental point of view, we have reduced use of what I would term virgin material and energy input, reduced waste and emissions, and also the fact that renewables are being used. Obviously, the waste can be used as nutrients in order to regenerate nature. Obviously, from a social point of view, we're looking at new green opportunities, green job opportunities through the use of the reuse of resources. As I mentioned before, the issue of sharing of the resources, this can increase the sense of community, cooperation and participation through a sharing economy. And finally, sharing the function and service of a physical product. These are obviously the contribution that a circular economy can give and that can contribute towards sustainability. However, before I end this short intervention, I would like to share with you some key policy directions that CE Malta feels will assist in the transition to a circular economy. I don't think this will come as a shock, but data collection is vital and necessary and very important for us, because it helps us identify and understand the flow of waste resources, especially at high levels, such as reuse, etc. So obviously data collection is a key policy direction. Another policy direction is to extend what we call the extended producer, but I would add also extended producer and consumer responsibility. Normally it's called EPR, extended producer responsibility, but from my point of view, I think we should also include the extended producer and consumer responsibility schemes, obviously to target specific waste streams. I think a key example of this is the beverage container recycling scheme that has been set up. Obviously, we are now looking at other areas together with other regulatory bodies to see the possible introduction of such schemes. Obviously, another policy direction is the support for product bans or the introduction of product standards, such as the use of single plastics, construction and demolition waste. So there on demolition waste, we're talking of creating product standards that will allow the reuse of the material. Introduction of recycling regimes in support of the extended producer and consumer responsibility, and introduction of waste prevention programs. So we at Malta are aware that the current systems of public policy and decision-making evolved when decision makers had time to study a specific issue and develop the necessary response or appropriate regulatory framework. The process was designed to be linear, mechanistic, time-consuming, but we understand that such an approach is proving to be ineffective or unable to meet the rapid change that businesses are undergoing. Obviously, we are being challenged to preserve the interests of the consumers and the general public while continuing the support of businesses towards the circular economy. So we are also continuously trying to adapt to this new and fast changing environment, reinventing ourselves so that we can truly understand what we are regulating and the rationale of this regulation. To do so, obviously, we need to collaborate closely with businesses and civil society, and participate in webinars like this. So I thank you for your attention, and once again, I thank the organizers for this initiative, and well done. Thank you.
Thank you, Anthony. Very interesting presentation, and very interesting to note the valuable work being done by Circular Economy Malta. Just taking a short quote from your presentation, I think elimination of the end-of-life concept is exactly what circular economy is all about and what we should be aiming for. So thank you very much for that.
Thank you.
Moving on, I would like to introduce my colleague from the Circular Economy Committee within the Malta Chamber, Corinne Fenech, who is also an innovation consultant and trainer from Think Things. She will be speaking to us about circular economy solutions. Thank you, Corinne.
Thank you very much, Oliver, and the engineer itself. So I am a 43-year-old entrepreneur and I don't have any kids. So people may ask me, but why would you care what world remains for the next generation? And after all, in business, we hear a lot, the business of business is purely business. Milton Friedman, a very famous economist in the 1970s, wrote that the corporate responsibility of business is to make profit. And although this may sound a bit peculiar, this has been taught in business schools since then. So it is not something new. I know that I have been lucky to see lions in Africa, to walk in Nepal over the snowy mountains, to visit cities in Europe, and to live in Malta while it is still not a desert. And I know that I am not alone in this, and that there are many other entrepreneurs and businesses who really focus on circularity. So today I would like to introduce the concept of circularity, furthering upon what Engineer Rizzo has said. And I would like to also note that it makes business sense to go into circularity. So let me share a bit my screen. Are you seeing my screen? Good? Very well. So a few years ago, the United Nations have introduced 17 Sustainability Development Goals. And I hope that everyone here is familiar with them. If not, please do familiarize yourselves with these, because nearly all the countries in the world have committed to reaching goals by 2030. And my talk today is focusing on the concept number 12, and that is responsible consumption and production. So the first part was we're going to be describing the difference between the linear and the circular economy, and then we'll be discussing business opportunities in what is called the butterfly model of the circular economy. And the circular economy is a concept that is very, very simple. It's like a line and a zero. The line represents the linear economy, the zero represents the circular economy. So if we have a look at the linear economy, it's very simple. We take what Engineer Rizzo has termed as virgin material, we take it from the earth, we make something with it, and we dispose of it. And this leaves us with two big problems. The first one is the finite resources, and the second one is increasing waste. Okay, so the circular economy is here to help us in the reduction of waste and in the problems which come with reduced raw materials. And the circular economy looks something like this. It means that we take raw materials as much as possible, we reuse materials, and we design, we produce, distribute, consume, and collect. So we include concepts of circularity in each and every step. Okay, there are three main different economies which we are quite used to. The first one is the one which we have hopefully left behind now, and that is the normal linear economy model, where we take, we make, we use, and we waste. Then there is the recycling economy, which we are getting used to quite a lot, and it has become, I would say, a good concept which every household knows. And that means that we take, we make, we use, and we recycle the waste. But then there's also the circular economy, and that means, hold on a bit, that means that we recycle, but also we return, we reuse, and we repair. And these are concepts which are very, very important in the circular economy. And I will be going into the next model. But before that, I would like to also make a point, a difference between having a less negative impact and having a positive impact. For many businesses today, we tend to think that corporate social responsibility is something which costs us money. So if we are working in a traditional business and we say that we're going to plant 20 trees, that is going to cost us money. On the other hand, there are business models which are being very effective, which are working within the circular economy and are making money out of it. And in that way, the business is going in circularity, whilst also making a profit out of that circularity. Now, I'd like to describe as well the butterfly model of the circular economy. This one was created by the Ellen MacArthur Foundation, and what you're seeing here is going to be a simplified version of it. If you'd like to have a look at it, though, there is a better one in the Ellen MacArthur Foundation itself. So if you have a look at the screen, there are two sides. There's the blue side of the screen, and there's the green side of the screen. By the green side of the screen, there's the biological cycle, and there is the food that is consumed. On the other hand, there's the technical cycle. So if I were to explain it using two basic things, this is a can of creamed corn, okay? And it belongs mainly to the biological cycle, although the can does not. And this is the mobile phone. So by the biological cycle, I'm going to be explaining the can of corn, and by the technical cycle, I'm going to be describing the mobile phone. And this is what it looks like. So we have in both elements, we have the parts manufacturer, we have product manufacturer, and the service provider. And there are business opportunities in each and every step of these, okay? So if we look at the biological cycle, the parts manufacturer is the actual farmer who cultivated the corn. Then there's the product manufacturer who made up this can of corn, and the service provider, which is the supermarket from where I bought it. Okay, when we look at the biological cycle, we are the consumers of what is produced. On the other hand, if we look at this mobile phone, we have the parts manufacturers which produce the internal components of it, the product manufacturer who brought up this, and the service provider is the shop from where I bought this mobile phone. Okay, so here we are not consumers, we are users. And obviously in the linear cycle, we have waste, which comes out of that. Now, the next part, though, is where circularity comes in. And the smaller the circles, the more effective we are. So the first thing is that we need to reduce the waste in the biological cycle. And that is where businesses come up with concepts like using wilted fruits to make smoothies, for example, etc. There we are reducing waste, okay? And that is less expensive than having to see what you're going to do with the waste. But then there are also business models which focus on restoration. Okay, so we have businesses which work, and I'm going to demonstrate one particularly works very well in this area. They restore the biomaterial back to the earth so that we can have new agricultural products. On the other side, there's the maintenance. So if I'm looking at this mobile phone, the first thing that comes to mind in circularity is making sure that I maintain it well. And not just I as a consumer, but there is money to be made from businesses who work in this cycle as well. We are very much used to businesses wanting to sell more and more. But nowadays, businesses are also working on making a profit through maintenance, through remanufacture, etc. So as you see, the maintenance here is a very small circle. But then there's the redistribution. So let's imagine that I'm done with this phone because I want to buy a new one, but it still works. Okay, and there is also businesses who are working onto the redistribution side, and we're looking at service providers who now redistribute and resell this product. There's also the remanufacture part. So let's imagine that this phone went faulty, okay, and it went back to the product manufacturer. This means that the manufacturer has remanufactured this same phone, changed some components and sold it back. And then there's the recycling part. As you can see, the recycling part is the one furthest away. And that means that it's the most expensive in the circular economy. It's not bad, but it's not as good as the remanufacture and redistribution and maintenance of the cycles. And that means that this mobile phone goes, it gets disintegrated and is made into something new. Now, innovation is very, very, very important. And that is where we come up with solutions for problems we have seen before. Okay, and I'm going to give a few examples of businesses which are working in this area. So we have Alginit, for example. These are people who are creating fiber from seaweed. Okay, we have this is the interesting example I was talking about. These solutions, they use the biodegradable material to feed these flies and then produce pupa. And what happens here is that we do not feed fish, expensive fish. We feed fish something which is not edible. And it's not just for fish. These are used as pet food and they are used as chicken feed as well. There's another example which comes from the Netherlands, which is Fairform. They have been working on this model a few years. I would say they're getting better, although it was a rough-edged start. They work mostly on components and they focus on maintenance and giving a fair wage to employees all over the world. And they make sure that it has a longer battery life because yes, battery life can be designed to be longer or shorter. Mud jeans, again from the Netherlands, they come. Mud jeans have between 23 and 40% of their products, they come from recycled goods. They have also entered what is called the slow fashion movement. And by slow fashion, we mean that we don't change our pair of jeans every year. There is the fast fashion and there's the slow fashion, and they happen both in the circular economy. So there are companies who ensure that clothes are biodegradable and their life cycle ends after, say, 10 washes. And there are others who are in the slow movement. And this means that you can rent a jeans and give it back to the company a year later. And then depending on the quality of that jeans, they resell it, remanufacture it, or simply recycle it. This is the final example, and this is Blue City. Blue City is a city made in Amsterdam. Okay, it's a place where there are startups in the circular economy. And just as an example, Rotterdam is a company which uses coffee residue to grow mushrooms, coffee residue from bars. Then the CO2 which the mushrooms released, it is used by another company called Spiro, which produces spirulina. It's a nutritional supplement. And then there's Fruit Leather, which is a company which makes leather exactly from that, from fruit. Now I know that for businesses, it's not very easy. And I have recently attended a seminar where Melissa Bastos, who is the director of markets research in Continent Incorporated, who explained there are three main challenges in the circular economy, which we need to overcome. The first one is the taboo, which is still associated with second-hand goods. We still want to own first-hand goods. The second one is technical. So if I've decided to sew a pair of jeans, then I would need everything to be in the circular economy, even the zippers, even the yarn, etc. So that is a technical difficulty. And finally, financial. Unfortunately, it is still more expensive to get circular recycled material rather than to get a new. I'm doing a research currently with a number of businesses in Malta, and I have asked them, can you be ethical and still make a profit? And do allow me to read this response because this one comes from one of my respondents. So this person told me, the cynic in me says no, in the sense that it seems that the idea that in business, in order to succeed, you need to squash your competitors and all these things. Having said that, I also want to make a difference between being profitable and being greedy. And that is where the distinction comes in. So if I want to, by hook or by crook, become a very rich man, I want to be the best in everything, it is very difficult to be ethical. But if I want to have a decent standard of living and get remunerated in the correct amount for the correct amount of work that I put into it, then yes, I can be ethical. And I do believe that businesses can be ethical and can make a profit. So if we have a look at which businesses are going into the circular economy, we're seeing a number of types. We have the explorers. The explorers are the ones who are at the forefront. They are the ones who are there and they are out there and they risk their limb. And they are the ones who fail most of the time. But they are risk takers. Then there are the pioneers. The pioneers are the ones who wait and see if the explorers survive. Once they see the explorers survive, they are at the forefront. Then there come the settlers. So they are the mass of the companies, which then follow the pioneers as well. And then there are the stay-at-homers. They are the ones who, no matter what you do, will never change. And the truth is that it's up to us to decide whether we want to be an explorer, a pioneer, a settler, or a stay-at-homer. To be honest, I'm a pioneer. I'd rather be. But in all fairness, there needs to be each and every one of them. So if someone asks me, what if I invest in the circular economy and it does not take off? And I would say, what if no one does invest in the circular economy? What happens then? So people are now looking at what is called the triple bottom line. And as Einstein once aptly put it, he said, not everything that can be counted counts. And not everything that counts can be counted. So I'd leave you with this. The business and planet prosperity are not mutually exclusive. Thank you very much.
Thank you, Corinne.
Thank you.
As you rightly say, businesses have an obligation to turn a profit, but they have other obligations also, social, environmental, etc. The challenge is clearly finding the balance between still making a profit whilst respecting the other obligations. And as we can see from your presentation, there are companies that are already managing to do that. So the possibilities are there. We just need to find more pioneers and more explorers, as you say.
Thank you, Oliver. Really appreciate it.
Moving on, we have colleagues from ELM Fabrications, so engineers Niki Borch and David Chiberras, who will be speaking to us about novel, sustainable, and eco-friendly value chains. Thank you.
Good afternoon, everybody. I'm Niki Borch, and with my colleague David Chiberras, we're doing a startup, and it actually covers all the aspects that Anthony, Oliver, and Corinne have said during their talks. So let me share my screen. Can you see my screen? Hello?
Not yet, no, not yet.
How about now?
Yes.
Yes, thank you.
So we are ELM Fabrications. The the title is Eco-Layered Masterpieces Fabrications, and we are a new generation of carpenters, and we're doing a digital transformation of the furniture industry. And this motivation came about when we saw a lot of negative articles online and on our newspapers that Malta is the worst recycler, etc. So we wanted to do something about it. And we chose one industry, which is the timber industry, which currently is, as Corinne mentioned, it is a linear economy. So trees are harvested, taken for timber, build furniture, and then when end of life, we either throw them in landfills or incinerate them. There's a growing demand for timber. Unfortunately, there are many forest deforestations because of the large demand, leading to illegal logging and loss of biodiversity. Traditional wood manufacturing creates huge waste, and there is limited use of the byproduct. And as even in Malta, we're feeling it, carpentry skills are diminishing. So the artistic touch of carpentry is being lost. So our value proposition is that we are changing the furniture industry into a circular economy. So we get biocomposites, which is the byproduct of wood and the paper industry. We'll go that more detail. And then from material, we do furniture, and at its end of life, we grind it, and we can do another new furniture from the same material and repeat the cycle all over again. We know for sure that the material we're using comes from sustainable forestry, forestries that practice sustainability and afforestation programs. It is 100% traceable. And we're using Industry 5.0, which is additive manufacturing and robotics for precision printing. And together with digital artists, we're working together to create affordable, beautiful, and customized furniture like this chair that we're showing. So we want to make an impact in 4 areas. First of all, first impact is the core business model, which is circular economy and carbon sequestration. Second, we want to promote a new symbol for sustainability. We want to change the way people think about waste. And finally, we want to make a global impact. So let's talk about our core business model. So basically, we're getting raw material, which is biocomposite material, and it's by itself is made up of circular economy as well. So its source is coming from circular economy, and it's coming from the residues of the sawmill and the paper pulp industries. And that means that us printing the furniture means that we don't need to harvest any trees to do that. It comes from sustainable forestry, from sustainable logging, and of course, reduce demand on new timber, and it's 100% traceable, 100% recyclable. And the beautiful part of this is that it's a climate positive product. So if you take into account the production emissions and take into account the bonded carbon dioxide that goes into this material, we come up with a negative value, which means that actually we are sequestrating carbon. So what we do is currently we are taking this special material, biocomposite, and we are using additive manufacturing, 3D printing, to actually create structures. They can be either small or can be large structures in the range of 2 by 2 by 6 meters. That is possible as well. So we're targeting different markets. It can be furniture for office, home, school, and street furniture, even marine, because the material allows for marine structures to be built, and architecture. And when the user, when the consumer is fed up of that product, we take it in again, we grind it, and we print something new. Okay, so we have this elimination of end of life and this circular economy even at our manufacturing site. So circular economy to get to this product, and circular economy again to do this process from the end product to a new product. And if you were wondering, this is not a coffee break, but the energy consumption of one 3D printer is the same, is even less than one kettle of one electric kettle, just to put you into perspective. So our innovation is that we want to be in the sweet spot here. So between the costs of a workshop, of a professional carpentry workshop with traditional tools, being for professional use, we did our feasibility study. It is a bit more than 45,000 euros. And we've in production, there are these 3D printers that range between 150K to 400K. The problem is that they return a low return on investment. So at Elmi Fabrications, we want to democratize large additive manufacturing machines and make them affordable and easily accessible to many companies globally that wish to start printing. And we're aiming for a printer that costs less than 100K with high ROI. And that comes with innovation and engineering that David and I are doing. Now, second impact is promoting a new symbol for sustainability. And these are the lines. So with printing comes lines. And I have a sample over here with lines. So we want to promote that these lines, these layers, which by the way can be observed occurring naturally in nature. And this is our inspiration, eco-layered masterpieces. So that's where our name comes from. And we want that to promote this idea that when you see lines in retail shops, for example, furniture being printed by technology like ours, that means automatically sustainable furniture. So coming from circular economy. We, as an impact, we want to change the way people think about waste. There's again the circular economy cycle. We can also do plastic. So today, I was going to throw away this detergent bottle, and this can be recycled together with there are some other initiatives collecting plastic here in Malta. If you take a look underneath each bottle, even in your shower gels, you will see a number underneath, 102, 102 being easily recyclable. So we can grind plastic as well and print street furniture, school furniture. So as a responsible parent, I can invest in the detergents, and in fact, instead of throwing them away, grind them and 3D print a slide for my children. They grow up, grind it again, I print a chair for my children. So it's a new way of thinking about your plastic waste, or in the other case, the wood waste. And it's a metamorphosis because it's changing a lot from one product to the other. So we want to make consumers take ownership of their waste and participate in a circular economy value chain, even themselves. So it's not far away from them. And our big third goal, which is our big, hairy, audacious goal, it is scaling up and make a global impact. So currently we're working on a platform and ecosystem whereby not only are we providing the 3D printers at a very affordable price and accessible, but we want to be Amazon-like platform, meaning that we are connecting three stakeholders together. We're connecting digital artists who can create beautiful designs that can be 3D printed. And there are many freelancers out there and many creative people. We want to connect them to 3D printing facilities all around the world using our machines. And that's how we scale up, because we make it affordable. And thirdly, the consumer. So the consumer can go online, choose the digital artist they like, or the furniture they like, order it, get it printed, and get it delivered to their homes. End of life, send it back to the nearest manufacturing company, grind it and reprint it to whatever you want. So the founding team is, there's myself, there's David, who many of you may know him as the guru of 3D printing here in Malta. He owns as well Invent 3D. and Pablo Piatola, who is our chief designer when it comes to designing beautiful furniture, and he's a architect. He's as well a major contributor in the Nokia 3310 design. We thank our funding partners. So we've received so far, we started in this year, and so far we've generated a lot of interest, and we've been funded now twice. One from the Climate Kick Accelerator, which is the CLIM accelerator in the Mediterranean, supported by MCOST and Tech.mt, and we also received finance from Takeoff in the last round to actually continue our R&D. Thank you. And if there are any questions, I believe they will be asked, correct me if I'm wrong, Oliver, at the end of the presentations, correct?
Correct.
Perfect.
Thank you, Nicholas.
Thank you all. Thank you all.
Thank you for this case study, especially interesting because it goes to talk about a resource. In Malta, we are short of many resources, and probably timber is one of the major ones. So especially interesting for that reason. Thank you very much.
Thank you. Welcome.
Moving on, I would like to introduce the next speaker. We will be hearing an intervention from Engineer Carl Lazzopardi, CEO from the Building and Construction Authority. Thank you, Carl.
Thank you, Oliver. Good afternoon. And I hope so far it's been really interesting. And for me, it's light through the tunnel on a personal basis. Obviously, circular economy is something that is at heart. Since my background is even in manufacturing. So I've been seeing circular economy for the past years, I think. And I would say Anthony and Ruben, Prof. Ruben over here, know about it. And I would like to start with a clear statement that government itself has set out in the Economic Vision 2021-2031, within those 5 pillars, an emphasis on circular economy. And how does that fit within the building and construction industry? I think it's one of the main aims that going forward, both in terms of recovery and beyond recovery, that circular economy would be key to successful interventions, all of this within the climate change team. And obviously, as a regulator, the authority being set up earlier this year, we've been in the past few months working hard on a strategy with a complementing plan that looks at transformation over the long term, focusing on the construction, obviously, industry and building industry. The authority's core would be the building. Any building is at heart. So the departure, the baseline is the building. The building that would aspire, that would essentially result into having a passport, and that passport would mean healthiness and going forward, promoting, obviously, the need to renovate rather than demolish and reconstruct. If that is the case, there's circular economy, and there are opportunities there for industry, even for the building itself and for all the ecosystem to gain social and economic aspects. Why? There are tangible proof studies and even prototypes today. We've just been hearing about a particular company now that is working specifically on wood, on timber. And similarly, there are all the other reconstituted elements that can become valid and viable going forward. This is something that obviously is key. It's something that works hand in hand with an authority who is building up its own regulations and new regulations. And I'm a firm believer that government should be the facilitator and even supporting in many schemes that are projected. Obviously, as a regulator, we see ourselves as being catalysts to promote, catalysts to drive the change, but obviously we are firm believers that the competence and the ability of industry would eventually drive and transform itself. So as a quick overarching introduction, the authority is looking at number one, having the first ever national building codes that would address or regularize the position when it comes to a building, both in the making of a building and post-completion in its occupancy when it comes to life cycle. So the idea is that in time, we start off with minimum criteria, with minimum standards, and basically start upscaling those standards to obviously address both voluntary, what is considered voluntary as a nation, initiatives of upscaling, of raising the standards in terms of decarbonization and related, and as obviously those that are mandatory, that revolve around the long-term renovation strategies and the directives when it comes to energy performance. And this is basically key. So setting up the market in business terms, there's a regulator, there's government, and there's the EU bloc that is pushing to create a market. So that's a guarantee that we will have a market, and there is a market. Time is of essence. So I'm a firm believer that manufacturers and industry who has already started investing, they'll be on the forefront to continue to make things better. Obviously, we will be looking at standards that at the end of the day will be in line with the targets that we require, especially when it comes to decarbonization. And circular economy is one of the models that fits perfectly decarbonization processes when it comes to a building. Why? Although smart technology, smart buildings that are their reliance is on the use of electricity coming from clean energy is good. We're talking here about let's make our buildings less prone to use of energy, more comfortable, more durable, getting back the second cycle, even the third cycle and fourth cycle of components, making buildings to designed to deconstruct eventually and reuse on a modularity basis. Obviously, this involves a change in culture across the full spectrum of the ecosystem. So we'll be looking at skills, and that is a top priority, and looking at even the professionals who will be looking our future in terms of specifications, and all of this within the atmosphere, the environment of a regulator. So one hits the other one, offsets another issue. So this is a key, and this is something that we will be promoting in the coming months to come in terms of regulations. Well, there's as I said, there's a long-term transformation plan. There is an immediate plan that focuses initially on awareness, on the need to renovate, on the importance of our fabric and the way we look at buildings in terms of reuse, and the importance on raising standards across the full ecosystem. Why? We need to have better specifications that promote circularity, specifications that obviously promote reconstituted elements, and obviously the need to send our message out there, what is really recycling, what is really reconstituted. We have to eliminate the perception of a recycled product or a reconstituted element is inferior. Definitely not. Both prototypes and materials that have been produced so far give clear indications that they perform much better than the even natural state. So this is something that has been proven, something that maybe Prof. Ruben Paul Borch will elaborate more into his discussion now. And this is something that we are really keen on making sure that our regulations are set to allow for further development and improvement on a step-by-step approach going forward. Our own aim and role would be to continue the front at the various forums, including the task force we have with CE and even ERA on a specific value chain and production chain of reconstituted elements, because it will be key going forward, and keep on lobbying and promoting the essential and critical model of circular economy that will partly or substantially resolve much of our landfills or related waste generation processes. That's my quick introduction. Obviously, well done to all the team, and look forward to continue on these lines.
Thank you, Carl. Thanks for your intervention. It's good to note the work being done by the authority. Construction waste is one of the most talked about waste streams in Malta. It's probably because it's one of the most volumetric, which also means that it is one in which lie more opportunities. So it is good to note that the sector is being regulated, that change is around the corner, and thank you for all your work. We shall be speaking about a similar topic very shortly from Professor Borch in terms of construction materials. However, before that, I would like to introduce the next speaker, who is also a colleague of ours from the CE committee within the Malta Chamber, Vanya Veras, who is the CEO for Vivacity Limited. She shall be speaking to us about embedded carbon and carbon sequestration. In your hands, Vanya.
Unmute. Thank you, Oliver. Good afternoon, everyone. Thanks for being here. So I'm just going to run through quickly what embedded carbon means and just tell you a little bit about what we're doing as a company in Malta. Oh, next slide, please. I'm trying to change it myself. Very quickly, embedded carbon is what you think it is when you hear the word embedded. It's the carbon dioxide or greenhouse gas. So that's the carbon dioxide equivalent in other pollutants, which is associated with the manufacture and use of a product or service. For construction products, and I mention construction here because we do green roofs and green walls, and also construction waste within the entire waste generation of a country is generally 80% of total waste produced. So for construction products, embedded carbon means the CO2 associated with extraction of materials, manufacturing, transport, installation, maintenance, and disposal, so waste. Most of this embodied carbon is CO2 emitted in the use of fossil fuels for the extraction and for manufacturing, but also from transport. The heavy materials, so transport is a big aspect of that. The construction phase of a building can represent 10 to 20% of the whole carbon footprint of that building. Next, please. Thank you. So this, we are looking at it in the context of climate change, and this is where circular economy and green economy come about. So with the growth of our cities and as they become more and more densely populated, we need to find methods for limiting embedded carbon and compensating embedded carbon. So balancing it out. The previous speaker, Mr. Atsopadi, mentioned a change in materials to more sustainable options. This is a very good option which avoids extraction in many cases. So we're talking about reuse and recycling of construction and demolition waste. This does exist in many EU member states, and we are looking at upcoming legislation by 2024, most likely, obliging recycling and reuse of construction and demolition waste. So this includes the reuse and recycling, but it also includes separation at source. So keeping construction materials separate in their waste phase to facilitate reuse and recycling. Coming back to buildings, one can manage embedded carbon and also carbon embedded during the use phase of the building through efficient design, designed to reduce wastes, designed for disassembly and reuse of parts of the building at the end of the life, so parts and materials, and designed for durability and adaptability. In many cases, we see buildings in city centers which were originally built to be warehouses or offices, and they are adapted and transformed into accommodation. This is part of it as well. Next, please. Thank you. So operational embedded carbon generally refers to the use of energy within the building. Most energy is used for heating and cooling, not so much for appliances as a percentage. Ways of overcoming this and reducing the energy consumption of a building are insulation design. So this is called passive design, using the heat of the sun to heat the building and wind currents to cool, but also to heat. Green roofs, which is another insulation method, and green walls, the same. These are techniques that we use as a company. Renewable energy, which replaces the energy from the grid, which will most likely still be carbon-based energy production. Solar water heating, again, reducing the carbon impact of the power production, and avoiding soil sealing. So every building that is constructed seals the soil that it is sitting on. The carbon impact of this is that the building creates flooding when it rains and reduces the amount of water which can re-enter the water table. The carbon impact of that is the need to capture water from the sea. Power generation is needed, clean water, but also manage the destructive effects of floods, which damage roads, damage property and possessions, causing waste. The floods in Germany this summer, it was calculated that it will take 4 years to treat the waste, because it can only be treated through waste incineration, as it's all mixed and dirty, which was caused by those floods. And this is because of limitations in waste incineration capacity. It's not plans to deal with this kind of disasters. Next, please. This is a green roof, which we installed for Economies in November last year. This photo was taken in September this year, so it was 10 months old. The water need is very low, and a green roof can reduce heating and cooling needs of the building by up to 75%. So this is valuable for offices, houses, warehouses, and computer server storage banks, which need to be kept at constant temperatures. So a couple of facts. We have now installed over 1,000 square meters of green roofs in Malta in approximately 2 years, because we're just minus COVID months. All of the supplies, so all of the materials that we use to make the green roofs are 100% recycled content. So they're made of recycled materials, and they are 100% recyclable. So there is zero carbon balance, which means that there is zero embedded carbon within those materials. And because this system does not use any chemicals in the soil to propagate the plants, there is no added carbon there from fertilizers. As I said, the watering need is very low. It's about 300 liters per square meter per year. And that includes Malta. It is a system which was designed for arid climates, hot arid climates. And just to come back to the construction and construction materials issue, this system weighs 60 kilos per square meter and therefore does not need additional strengthening of a roof in order to implement the green roof. So it is very easy to retrofit. So it's a good technique to use in renovation and even deep renovation. Next, please. So just a calculation that I did using Maltese energy data and possible CO2 and CO2 equivalent savings using green roof ecosystems. According to Maltese carbon emissions from electricity production and average use in Maltese households, the emissions per 50 square meters of roof per year are 1.29 kilos of CO2, and per 100 square meters of roof are 2.59 kilos per year. It doesn't sound like a lot, but when you add it up, it adds up to a rather large sum, which adds to Malta's exceedance of CO2 emissions according to the European emission limits per year. Now, when we look at how much CO2 our green roof ecosystem can sequester per meter squared per year, the calculations come to, sorry, that's not per meter squared, that's per 100 meters squared. It's 23 metric tons per 100 meters squared. So if you compare that to the amount of kilos emitted by that building, you're sequestering a great deal more carbon dioxide and equivalent than is being emitted by the building, which addresses other CO2 emissions, for example, from transport, and can be a very effective tool in managing Malta's overall carbon emissions and path towards carbon neutrality. Next, please. So quick EU update on related legislation and policy to embedded carbon. So in July this year, the Commission adopted a proposal for a regulation setting up a new carbon border adjustment mechanism. What is this? It is an obligation for importers into the EU to report the embedded emissions in certain carbon intensive products, initially aluminium, cement, iron, steel, electricity, and fertilizers, and to buy certificates to account for those emissions. This is to complement the EU emissions trading scheme. It is a mechanism which was invented to ensure that production of carbon intensive goods does not shift from within the EU to cheaper laxer third countries. So this has two aims. One, the first obvious aim is to not have environmental shipping and giving that obligation to third countries, but also to protect investments which are made within the EU market. And this is something which is always brought up when such new legislation comes into effect. So this will come into force from the 1st of January 2023, so about a year from now, and it will gradually take effect, fully operational by 1st of January 2026. Next, please. This is part of the EU's Fit for 55 policy package to reduce greenhouse gas emissions by at least 55% compared to 1990 levels by 2023. And this is part of the European Green Deal. Once this mechanism is fully in place in 2026, importers will have to apply for authorization from their national authority before importing goods which are within the scope of this regulation. Next, please. So following on our buildings theme, the Energy Performance of Buildings Directive is under revision. This requires a national long-term renovation strategy for the decarbonisation of building stocks by 2050, setting minimum performance requirements at cost optimal levels for buildings undergoing major renovation and meeting the nearly zero energy building criteria. Originally in the current directive, this criteria is effective as of this year, 2021. It also prescribes the issuance of energy performance certificates. I know that these are available in Malta and used in part, but in order to implement this directive fully, they would need to be more closely integrated into sales and rental agreements. Next, please. So the impact assessments preparing for the revision of this directive has looked at these following issues, and these are the proposals. So a phased introduction of mandatory minimum energy performance standards, which look at scope, timeline, and type, but these are still to be defined. Better quality, accessibility, and diffusion of energy performance certificates, also through greater harmonization across EU member states. The possible introduction of building renovation passports, previous speaker also mentioned that, and integrating deep renovation standards into the sustainable finance legislation. Again, a possible revision of the requirements for nearly zero energy buildings and measures for sustainable mobility connecting buildings within cities while addressing circularity principles and resource efficiency. Next, please. Then it is looking at introducing a higher target for reducing primary and final energy consumption by 2030, up from 32.5% to 36%. It is now binding at current levels at EU level, and this is in line with the climate target plan. They are thinking of introducing a benchmarking system for member states to set their national indicative contributions to the binding EU target, and nearly doubling member state annual energy savings obligations in end use. At present, the obligation is 0.8% per year, but the proposal seeks to raise this to 1.5% per year, starting in 2024 and aiming for 2030, before which there will be another revision. Next, please. Other policy areas which will affect construction and the urban environment are the EU Biodiversity Strategy 2030, the EU Soil Strategy roadmap at the moment, and of course all of this is underpinned by the European Green Deal. The Green Deal focuses very much on bringing greenery into cities in order to control temperatures, to control the inner city climate. Not only oxygen levels, but using greenery to cool the air and to cool buildings, and thereby reduce the need for air conditioning, which heats the outside air while it is cooling the indoor environment. So that's the EU update. I believe that I have finished. Next, please. I think it's the last slide. There we go. Thanks for listening. These are my details. Happy to answer questions. Thank you.
Thank you, Vanya. We all know how carbon neutrality is essential in terms of protecting our environment and lessening our impact on the environment. The reality is that because of the impact we've already had, carbon sequestration methods are also essential, if not more. And green infrastructure, including green roofs, are one of the pillars of this. So thank you very much for the detail in your presentation. Moving on to our last presentation from Professor Ruben Paul Borch, who shall be speaking to us about recycling, low impact building and construction materials. Professor Borch hails from the Faculty of Built Environment at the University of Malta. Thank you, Professor.
Good afternoon. I'm sharing my presentation. Can you see the presentation?
Yes. Yes, thank you.
Okay, so first of all, thank you for inviting me for this presentation. I shall be focusing on low impact materials first and foremost, and I shall also be drawing on some professional and academic experiences, referring to some success stories, but also identifying some gaps which we could address in contributing to the circularity in the construction industry. I would also like to acknowledge various research assistants who have supported me in some of the projects or products or items I will be sharing with you. And as a premise, I would also like to start off by mentioning the fact that as an archipelagic island state, let's say, we do have some peculiarities in terms of our situation, which would merit a deeper understanding of the situation with resources and waste, or rather, as I shall be referring to waste as byproducts. First of all, I would like to kickstart by referring to decarbonization and climate-proof construction. Why? Because if we look at the year 2000, I'm referring to this chart from the World Resources Institute. It already identifies a number of sectors which contribute directly to global emissions and which are intimately associated with the construction industry. And incidentally, 20 years later, we have the same situation, or rather it's even worse, where most greenhouse gas emissions reported as recently as 2019, even though the chart from the World Resources Institute refers to 2016, one can already see this dramatic increase in emissions associated, as I said, in most cases with construction industry or construction processes. So this is a first reference to materials resources we consume in our industry. Referring to a publication which I came across recently, well, it's 2019, but it refers to decarbonizing our industry, and it identifies 6 items which we could do as an industry. And out of these 6 items, I could see that 4 of them, which are repeatedly referred to even in other research and in other publications, let's say, are directly related to materials, the way we deal with products. You can see here we have more efficient use of materials. Other speakers mentioned how we can extend the life of our structures and buildings rather than demolition and getting more waste. How to switch to low impact, low emission materials. How to use low carbon cement. We can already see how cement, concrete, is being identified as a core issue, even because of the huge quantities we produce and consume globally, not only in the industry, knowing that cement, concrete is second only to water in terms of human consumption. And then we have recycling of building materials and components. So we already see here this important observation referring to materials and the impact of products in the industry. And even more, a recent document which was published by the European Commission, which refers to climate proofing of infrastructure, would go on to refer to circular economy considerations directly, even when discussing how to best deal with climate proofing our infrastructure. And this gets us to think even deeper on how we are dealing with resources and our byproducts. As a summary, when we look at raw materials, waste, and their impact, we need to acknowledge that the construction industry is the largest consumer of raw materials and resources, therefore contributing to a significant amount of carbon emissions. It's one of the largest producers of waste, and this is increasing, whether we like it or not. It is also an industry which consumes resources and generates these large quantities of waste, and therefore creates opportunity for recycling. And there is a growing demand for construction aggregate worldwide. And this is even expected to continue increasing with time. So there are effective solutions, and there are two important solutions in the industry which refer to materials. So I'm referring primarily to materials today. And first, the replacement or part replacement of natural aggregates with recycled materials. And the second is the exploitation of mineral admixtures and supplementary cementitious materials to get rid of cement, or at least to lower the impact of cement in the industry. And therefore, I would like to focus on some possible solutions, some of which have been tried and tested even in industry, and some of which are reaching the market now or shortly, or have already been introduced in the market, and which can help us better understand that there are indeed some solutions. No solution is perfect. No solution is addressing all possibilities, but we can definitely exploit options in order to have a better construction industry which relies on improved exploitation of resources and a reduction in the generation of waste. So let's look at low impact product number one. So low impact product number one, which I must say is in some instances already introduced in construction, at least on a large scale in most European countries, perhaps not yet on a large scale in Malta, is the exploitation of mineral fillers which originate from waste and self-compacting concrete in large quantities, in certain instances as part replacement of cement. And this is some research which was conducted at the University of Malta, actually extensive research over many years, where a large amount of limestone filler was exploited to produce high-performance concrete, self-compacting concrete, which facilitates production, facilitates construction, and reduces the impact of the construction process itself, thanks to a more innovative product material. And this in combination also with exploitation of recycled aggregates, leading to some interesting outcomes, which, as I said, well integrated then in industry. Why? Because exploiting these mineral resources, which originate from waste, therefore byproducts from other processes, have indeed led to improved performance of these materials. And this is key, because we are not dealing here with inferior products, but with improved products, thanks to the waste itself. Impact product number two, which is also a successful product, which we use in large quantities and which is on the market and expanding actually, based on waste, where we have developed at the university concrete blocks, using the basic technology, which rely exclusively for the aggregate components on waste, on a byproduct, which is globigerina limestone, which would merit a minimal of treatment in order to be exploited to produce these blocks. Therefore, we are seeing here the elimination of use of new aggregate, and indeed the take-up of this waste material, which most often we consider as a waste, but in reality offers a golden opportunity for exploitation without much processing, I must say, because we are here dealing with a well-known industry, the production of vibro-compacted blocks, which is, I must say, one of the most popular construction products we have in the industry. Low impact product number three. What we have here is a filler which can complement and be used effectively in concrete, once again, normal concrete, and which can lead to improvements in concrete durability, if used well. So this is, of course, requiring, therefore, improved production in our industry, at times necessitating not necessarily new plants, but better precision and improved skills in the industry, greater awareness of quality. And this has been well tested, even with respect to durability performance, because we are indeed interested, as other speakers have mentioned, in the longevity of our structures. How long would they last? So we are interested in having more durable products, which means we have structures which last longer and which are replaced less frequently, therefore saving on natural resources and better exploiting our materials. Low impact product number four. It's a product I'm quite fond of, which is currently being developed in terms of intellectual property at the University of Malta, which with a small team I developed as a concrete without cement. Now, this is, I am fond of this product because it does away with cement as a polluting product and leads to a high performance concrete, which can be suitable for various elements, which can be easily used in construction. And various research projects over the years have led to quite interesting results, indicating that this product is so stable when it comes to longer term performance once again. And as I said, the innovation here is to eliminate the use of cement as a binder, to exploit large quantities of the waste we generate, which, as I said, I would rather call a byproduct, propose it as a low impact material, but definitely also propose it as a high performance product for industry. And as I said, it's basically extracting our waste from which has been dumped, or waste which is generated when we excavate, and transforming it into a high impact product. Low impact product number 5. And once again, we have exploitation of our natural resource, limestone and other waste deposits, to produce a rather attractive and interesting architectural product, reconstituted stone, or as referred to in Europe, in the UK, and in America, as cast stone, where one can exploit this engineered product in order to produce technological assessment of the raw material and then production of actual products, a product which is similar to a natural stone, a natural limestone. In some other cases, in other countries, it's a natural product they would extract normally, but which can be engineered to have improved performance, both in terms of strength and durability. And here, relying on different options for technologies. And here we see also different developments, even in Malta, for different options for production, which can indeed reach the market to, in some instances, have these architecturally attractive blocks, which resemble limestone, of course, but which can have engineered characteristics. Low impact product number 6. And this is very interesting because we are here looking at having exploitation of limestone, large quantities of waste limestone, in order to produce lightweight blocks. This has been successfully done in academia, in our research facilities, by my students and by some of my researchers, my collaborative researchers, where we have produced low density blocks, which can easily also be exploited as insulation blocks, but also to introduce new concepts in construction, where we can have also frame structures which would rely on demountable walls or demountable lightweight partitions. And we've also tested it thoroughly in terms of the thermal performance, whereas in fact, we've been exploiting this as a product, as an insulation product, either using it in combination with existing blocks or also as panels, which can be used in retrofit applications or even new construction, because these products can be developed even as load-bearing elements, for example. And once again, this is very interesting because this has reached the market actually. And of course, in this case, it would be competing, it is competing actually with whatever is imported into Malta. And that's why I would refer here back to the initial premise, where we have to take into consideration the fact that we import everything, which means there is an embodied energy in whatever we consume in the industry, thanks also to, unfortunately, to the shipping, transport, which is required. And therefore, this highlights the importance of making good use of our resource, local resource. Well, shall we push the boundary? Why not? In our research, one of the most cited research we have in our faculty, in our group, refers to exploitation of plastic. This was research done many years ago, actually, which is well cited even today, where we managed to transform plastic bottles into an important product. And I'm aware that Italian companies exploiting this commercially in order to enhance the properties of concrete. normal concrete. And we've tested it thoroughly, published it well, and we've obtained really interesting results, even in order to improve the properties of concrete. So we are here improving on whatever property you can get with normal concrete by having concrete with improved early shrinkage cracking, for example, or improved drying shrinkage cracking performance, and in terms of controlling cracks, but also in terms of improving hardened properties, flexural properties, and toughness of the material. And even pushing further the boundary. Well, this is not yet commercial. Perhaps it can be one day, but why not? Exploiting an invasive species, even though it characterizes our landscape, but exploiting extracts from this plant. We've analyzed this thoroughly and published this work where we exploited what we can extract from Opuntia ficus indica in order to produce a concrete with improved performance. And this works, it works fine. It led to improved properties in terms of early stage properties of concrete and dealing with concrete when it's still workable. Well, so I've referred to some products which are either on the market, we've developed in our research and pushed them into the market, or else they are close to being exploited as reconstituted products or whatever one would like to call them, recycled products. I prefer to call them engineered materials because they can be engineered to suit any application, whatever need, intended application, if I am to use the terminology of the European regulations and European codes, any application, intended use, one intends to exploit them. But how can we really measure the impact of these materials? How can we avoid falling into the trap of greenwash? Because some items, some ideas can be really interesting. But then when you really measure the true environmental impacts and when you measure the true circularity, let's say, one starts realizing that there are flaws in the way one is presenting the information, which can easily be highlighted. So we rely on life cycle analysis, and this is an important tool which we exploit. We've exploited it for Globigerina limestone blocks. We've exploited it many years ago when with the twinning project, we were developing cast stone. We exploited it in developing hollow concrete blocks with waste materials. And we exploited it even in more detail when transforming waste into a recycled aggregate, demolition waste into recycled aggregates, in order to get a useful product, but which is truly sustainable, which is truly contributing to lessening the environmental impact. And these are some of the life cycle studies which helped also define a better concrete, relying on alternatives to cement, what we call supplementary cementitious materials, or concrete which relies on recycled aggregates. And skipping on to an important item, thanks to these supplementary cementitious materials, thanks to concrete based on waste, what is remarkable is that you can actually get more durability in our structures. In fact, most of the high durability concrete we develop relies on waste materials. At the moment, in our research team, in my research team, we are engaged on a number of projects, mainly related to major infrastructure in Malta, related to heritage structures, which we still use and exploit, but also related to blocks, where residential blocks and other properties, where we are trying to understand how to extend their lifetime, because demolishing these buildings would create a problem. And we are aware also that the largest problem, challenge in construction, which accounts to at times half of the cost which goes into construction, is related to repair of reinforced concrete structures because of degradation, because of inferior quality materials used initially, but also because of lack of maintenance. My colleagues earlier mentioned maintenance of structures and infrastructure. So dealing with these structures, dealing with degradation and how to look at life cycle structure engineering is very important. And this is where in our core research, in my team, we are developing self-healing materials. These are materials which are no longer based only on research. We are exploiting them at industrial scale. In fact, some structures in Malta, even residential blocks and even large projects, rely on self-healing additives which are used in order to improve the lifetime of these structures. What we do in our research is to even refine further on these products. And what you can see here is the healing of a concrete, lessening the need of maintenance, even knowing sometimes that we might not be so effective in dealing with maintenance strategies. So relying on self-healing materials is really a good opportunity for our industry in order to contribute to extended lifetime, and therefore contributing directly to circularity in construction. But shall we look at it as we are dealing with waste or dealing with byproducts? In a forum I chair, international forum I chair, where we are developing high impact materials based on byproducts, we eliminated some years ago the use of the word waste, because most products, in reality, if you look at fly ash, which I've really worked a lot on, fly ash, it's a product you buy, but it's a waste, a byproduct from the burning of coal in power stations. But it's a product, you buy it actually. And the same with slag, the same with some other materials we use so often in construction. And it's these products which are even costly and which contribute to improved performance in structures. And to address this, years ago, we embarked on this activity where we developed a guideline document to classify waste. Allow me to use the term waste, for an instance, where we used we developed a guideline to transform waste into a resource. How? By classification. But classification for Malta cannot be done by simply seeing what the UK is doing or what European countries are doing. So we had to develop our own standard based on our own possibilities and limitations, because we have our own materials. So whereas the framework is related to international standards, the standard developed at the University of Malta in collaboration with MCCAA, Technical Committee 800, and also thanks to the support, financial support through a collaborative agreement between the Building Industry Consultative Council and the university, was precisely to be sensitive to the, well, peculiarities of Malta, peculiarities of our waste. The need to look at this standard as addressing the demands of industry. It's used as having a classification without seeing that industry can well exploit a Class A, Class B, Class C, Class F material according to this classification, which is based on years of assessment of waste materials and products in order to, as I said, transform these materials into a byproduct. So this is key for the industry. It's an important tool for the industry to be able to make good use of this byproduct for new materials. And another key item, which is very important, is, I think someone mentioned it earlier, a number of speakers actually mentioned, looking at what comes out of whichever process we deal with as a high performance material. And in fact, a recent research we published as a group with international collaborators, it's actually a dramatic step in producing a high performance concrete for high-end applications, which is even better than the original concrete. But this is entirely 100% based on recycled concrete and reaching really high performance in terms of durability when it comes to chloride penetration, when it comes to gas permeability, and when it comes to dealing with toughness of the material. So this is, I think, where we should be aiming at. We should be looking at high performance materials which can be well exploited by industry. And how can we implement circularity? Of course, there are various barriers, but also opportunities. Moving from improving the research base, but also looking at economic feasibility, market opportunity, go all the way to having a vision for the industry, how to best exploit the different solutions we can rely on to have, as I mentioned, better durability. And this is a preliminary attempt based on some economic studies we are conducting on what can really benefit and what can really benefit in some situations, because not any product, any solution is ideal for all applications. And these are all opportunities one can look in through various studies. And finally, how can we look at opportunity through applications for the construction industry? And well, there are initiatives which are taken by industry. I will share with you what I can, because these are projects I led or I was directly involved in, but I'm sure there can be others, even in the future, which can be well well considered as best practice examples. And first, for example, this is quite dated actually, but it was perhaps one of the first where we, on a large scale, we studied in detail the extraction of large blocks as an alternative to traditional excavation, precisely to avoid having waste in the first instance. And this was quite successful, and the study gave very interesting results from a life cycle analysis, life cycle impact perspective. Another study, which was also done with industry, is when we recycled all the concrete from the demolition of this bridge, Manuel de Meck Bridge in St. Julian's, where it was well studied, well characterized, and it was used to produce a high performance concrete. Even because it was well treated, well sorted, and used to exploit on a large scale. Another instance is where we attempted to see how to refurbish instead of demolish. In this case, it was a radio relay station, which we convinced the authorities has cultural value as industrial heritage. This is about 15 years ago now, but it was used as a test case to recycle materials and reuse them in the structure and monitor this process. Of course, you can see the gradation here. We classified the waste patiently, and we reused this material for the new product. Sorry for that. And this is the end result of a case study. I know it's dated now, but at the time, I think it's about 10 years ago when we concluded the whole process of monitoring this research station. It's actually a research station used now for educational purposes at Chroplagene. It was awarded at the time an international award thanks to the reuse of industrial building and recycling of materials. And allow me to share with you a latest structure. Fast forward to actually last week when we commissioned in our team a University of Malta project in collaboration with government, where we refurbished a structure which was going to be demolished. It's industrial heritage, but we are using it as a test case to show how to conserve water, but also how to value industrial heritage. And last but not least, how to introduce new technologies. Here we have highly advanced, high-performance materials, self-healing materials, which are used in different ways, appropriate to the needs of the structure, and together with a structural health monitoring system in order to refurbish heritage. And then we validated it actually last week in order to make sure that thanks to these highly advanced materials, entirely based on waste, so we have here waste-based high-performance materials, you can achieve actually higher performance, something which in this case you could never achieve with a normal concrete, with a normal material. So it's only thanks to recycled waste materials that we could achieve this high impact, high performance. Okay, thank you for your attention. I have here an image of a lump of material which is, well, it's more than 5,000 years old. It's from Gigantilla and it's concrete. It's perhaps the oldest piece of concrete around. And I show this and I share it sometimes with my students also, because it reminds me that what I've just shown you, after all, is an evolution of what was already done so many years ago, thousands of years ago, based on the same ingredients. We are dealing here with basic ingredients we get from the ground and which we should really use wisely, because it's a finite resource, and if we use it wisely, it can really last. It's a durable material. Thank you.
Thank you very much, Professor Borch. Conscious of the time, I would like to actually possibly conclude with one question to Engineer Oliver Fenwick, which is, what are the opportunities and challenges for us to achieve our circular economy goals in Malta, Oliver?
I think I will start from the challenges first. I think the challenges are more to do with culture, with a way of thinking. And that is where I think the largest change needs to come first. Okay, that circular solutions, that what is not necessarily brand new doesn't mean that it's not good. doesn't mean that it isn't fashionable. And that very often, or rather more often than not, something that is brand new, manufactured from virgin materials, has a huge impact on the environment. And unless we do something about it, that environment is going to cease to exist. So that is the challenge. Okay, the opportunities, as we've seen throughout this hour and a half, are various. They have been for a long time staring at us. The last example that Professor Borg just detailed is testimony to that. Okay, that thousands of years ago, people were already looking at reusing materials, at lessening their impact. Okay, so the opportunities are there. It is ample time for us, for the business community, to step up and do something about it.
Excellent, Oliver. Thank you again, Professor Borch, and to all the speakers. Those were some of the most interesting presentations I've seen in a while, actually, because we got an overall perspective, but we also got to go into great detail in many different fields. And this, of course, was just a sample of some of the creative solutions we've got in the field of circular economy, but we've got many more, and including in the field of low impact construction materials. So thank you, everybody, and I look forward to working with you all on behalf of the Chamber of Commerce. Thank you very much.
Thank you.
And good afternoon and happy weekend, of course.
Thank you.